Hello? Okay, cool. There we go. So, let me just stop this. Hello. I'm going to kind of situate myself. So, today, for those of you on Instagram Live, I'm also doing Twitch, and I have on Twitch a feed from the Instagram Live, and I also have some other information. I have the schematic of what we're going to be building today. And I'll be kind of like going through some other stuff as well. If you want to check that out, the link is in my Instagram bio. So today we're going to be building a VCF, which is a voltage controlled filter. For those of you who are not super familiar, I've been building circuit boards as part of my sculpture practice, and I've been getting very, very deep into analog circuits and the sort of like core modules of them. So last week, maybe 2 weeks ago, did first module in this series, which was a VCO, which is an oscillator, so our first sort of like sound source. And today we're going to be building a VCF, which is a voltage controlled filter. VCO is voltage controlled oscillator. So why do you want a filter? A filter is really great for shaping the sounds, or like the core sounds that you are working with when you work with sound synthesis and sound synthesizers. So a filter, there's sort of there's four sort of main types of filters. There's high pass, low pass, band pass, and notch pass. So if you were to think of like a graph, low pass lets only the low frequencies through. High pass lets only the high frequencies through. Band pass will only allow a select sort of band of frequencies through. So think of like, just a little like bip that just sort of like can be moved back and forth. And then notch is the inverse of that, so all frequencies except for like, a small range or something. So what we're going to be building is a low pass filter, which is like a really, really classic synthesizer sound module. So if you think about it, it's something that can like, take all the high frequencies out of your sound and give it like a really good sort of like low bassy tone or something. So basically I'm just going to build this. I'm going to sort of talk about it as I'm building it. I have the schematic as well, if anybody's interested in me talking about that, the sort of way this actually works from a core building block standpoint. And then when I build the whole thing, I'm going to plug it in and hopefully it works. And I have sort of my other module here that I'm going to use in like conjunction to sort of test this thing out. So yeah, let's just get into it. I'm going to start with, I like to start when I build one of these, any circuit board, I like to start with the smallest components and sort of build my way up. It's sort of easier to solder them that way. So my soldering iron, I've got all my components laid out here, and I'm just going to start going. I also have a printout that I like to mark up with all of like the components. There's something else on the back. All the components that I'm going to need, and then that way I'm not like sort of scrambling as I'm building. Sorry, I'm looking this way to the components, but my microphone is right here. So the first thing that I'm going to start with is the resistors. I talked a little bit about this with the first build. The resistors are just sort of like a very core component of like any sort of circuit. They just help you sort of change, the amount of voltage, the amount of current, going from one place in the circuit to the other. They can be used for other things as well, but that's sort of like the very basic core understanding of them, is that they just help you sort of resist the flow of electricity. And they come in every different variable imaginable. I just put in the 10 Ks. Now I'm putting in the 100 Ks. We have mega ohms. I mean, they run in ohms. So when you say K, that's like 1,000 ohms. So 100 K is 100,000 ohms. A 10 K is a 10,000 ohm. A 1 M is a 1 mega ohm. And so yeah, I can just sort of like build this out. Finish the 100 Ks. We've got 1 mega ohm. Yeah, this circuit is, I really like this circuit. It's very, very simple. It has very few components, and it just has like a really nice sound to it. It was sort of, it's the first filter that I built that I sort of like was able to get functioning. And I really like it. I've been trying to get into other filters now because I just want to sort of continue to explore more sounds. And you know, a high pass filter has a totally different sort of sonic landscape than a low pass filter, just from its nature on how it can sort of function. That's backwards. So I've just moved on now to the diodes. And diodes, I don't think we had any diodes in the VCO. So a diode, all of these sort of components have like, you know, very niche uses. So a diode is sort of something that, it's sort of like if you think of electricity like a flow of water, then and a resistor is sort of, you know, thinning the pipe so there's more resistance, then a diode is sort of like a valve. So it's something that if you go through, you can't come back. So diodes can be used to help prevent shorting something. So if you plug something in, if you plug in something that requires DC power, which is, you know, positive, negative, if you plugged it in backwards and you fed the positive side into the negative side and the negative side into the positive side, you could, in theory, use a diode to try and stop it. And the diode would sort of take all the brute force of the reversed polarity of that. They also have other, you know, abilities. They can drop voltages across them. They can be used in other ways as well. But the sort of basic understanding is they keep the flow in one direction, or they stop the flow in the wrong direction or something. Okay, next I'm going to move on to the capacitors. And we have different types of capacitors this time. Last one we only had ceramic, which are these. A little ceramic capacitor. I don't know if you can see that. Just a little nub. Very, very small little thing. Far. There we go. Not really in focus, but very small little thing. So I'm just going to get these in. And these also, capacitors have a lot of different properties to them. Come in all different shapes and sizes, and I feel like I still haven't. I've been doing this for a while, and I feel like I still haven't used every type of capacitor. Just because there's so many different kinds. I like just this last year came across these capacitors that are these like red rectangle, like these are all circular discs, and I have ones that are electrolytics, which we are gonna, you know, sort of get into today, which are a little bit different, but like, you know, these have a little different bit of a shape. They're more cylindrical. These are more like discs, ceramic ones. These other ones, they're called polystyrene ceramic or polystyrene capacitors, and they look totally different, very far out. Never seen anything like that before. So, to capacitors. at a bunch of different values. And capacitors come in the unit of measurement known as a farad. And farad has different sort of prefixes that get put onto it. So you have microfarad, nanofarad, picofarad, other sorts of farads. We just put in a couple nanofarads, a couple picofarad, or a couple, what is it? It's nanofarad. What was the first one? Nanofarad, picofarad. Anyway. Normally it's just abbreviated to NF, PF, UF. So here we have I've just finished the ceramic capacitors. Now I'm moving on to, the ceramic. Now I'm moving on to the electrolytic capacitors, which look like this, sort of like cylindrical looking things. And the fun thing about these is, they're polarized, which means that they have a side that's positive and a side that's negative. And they have to be connected that way, otherwise they won't work, or they might pop and get burned out. And so the ceramic ones aren't, and the resistors are not polarized. They sort of can be put in either way, back or forth. These ones you have to put in the right way. So usually I mark it on the circuit board, but in this case, I didn't, and I did that, because I didn't want to have a bunch of signs on this specific one aesthetically. But on my cheat sheet, I have done that. So I know that the longer leg is positive, and I've marked here that positive is on the bottom. And these are pretty big, so I like to bend out the leg on the bottom. So someone in the Twitch just asked, how are you doing this? Oh, how are you doing this Fine Friday? What are you working on? I thought it said, I read it originally as, why are you doing this on a Friday? To which my answer would be because it's kind of raining and I've just had a busy week. I wanted to do this earlier in the week, but I didn't get around to it in time. And last week things were just a little too crazy with the election, so I didn't really want to, step in on that. I kind of wanted to remove myself from the world for a bit. But how am I doing? I'm doing great. I've been here all day. I share this studio with my roommate, who's a wonderful painter. And I got to work on, I've been building a frame for him. And I was really excited about it. So I just sort of got to work on that frame today and worked on some other artworks around the studio that just needed some like basic maintenance stuff, and sort of just prepared for this. This is something that I've been enjoying a lot, because I kind of have a couple more big circuit board collages that I'm working on that just need to have their boards built. So now what I'm going to do is I'm going to solder everything out. Just because we're sort of done with all the capacitors, the diodes, the resistors, and all the smaller components. So yeah, how are you doing, Deep Daisy? Or Dishy? Deep Dishy. Deepy Dishy. So normally I'll just tack the top, just sort of like zap one side, and then I'll take it out. I'll trim all the legs, and then I will, oh actually I have the electrolytic, so I'm going to just zap that guy. And now I'll just like trim everything, all the legs, and then I'll just, hit the rest of them. I don't have to worry about the legs getting in the way. Yeah, I've seen some people sort of, put them in, fold all the legs, and then they flip it, and then they solder everything, and I don't know, I don't really like that way, because the legs never really cut totally flat. It just kind of gives it a slightly different look that I don't really like that much. But now I'm going to flip it, hit this other side. Yeah, Deep Daisy sounds like it has some sort of relation to, like the first computer to sing the Daisy song. I don't know, I thought you were referencing that or something. And that's cool. What other stuff have you been seeing on Twitch? I'm fairly new to this platform. I have a couple friends who have been doing really cool stuff on Twitch that are also artists. And I really, really like the way that they're utilizing this platform. I think it has a lot of potential for artists to sort of, do cool stuff with it. I feel like the software is really great for it. It's a little untouched, which is cool. So now that I've gotten those all soldered, I'm going to add my trim pot, which is just, a variable resistor that is meant to sort of, be more of like a fine-tune thing. And in this circuit, it's used to adjust the levels coming in, because the idea here is that there's going to be, there's going to be 3 jacks. One jack is going to be for inserting whatever sound source. In our case, it's either going to be, like noise, if we want to filter noise, which has a really nice effect. Filtered noise, or noise that goes through a low-pass filter tends to sound like wind outside of your home, or like waves on a beach or something. It's very nice. Or an oscillator of any shape or size. A square wave, triangle, pulse, saw. So we're going to be putting a sine, or a triangle and a square wave, because that's what I have on one of these boards over here. And so you'll have one port to plug it into there, whatever your source is, and then another port to send it out to whatever your mixer or sound source or whatever. And then there's going to be a third one, which is going to be for CV, or control voltage. And that'll be so that, we can take another signal or sound source and send it into here and have it modulate how much the frequency is open, or how much the filter is open, so you can kind of get like, if you have it really subdivided, you kind of get like a crazy sound when it's, running through. But I'm getting ahead of myself. So now we're going to put in the regular potentiometers, with a 10K and a 100K. And the reason there's 2 is because this filter has something called like an adjustable parameter for something called resonance. And resonance is a sort of a feature of a filter, because in this case our filter uses something called an operational amplifier, or an op-amp, which I talked a little bit about last time, because that's what we used for our oscillating source. But in this case, there's a little bit of feedback that's coming back into the filter, which lets it be slightly amplified, and the resonance can kind of control how much of that feedback is going in, and it gives a really nice sort of squeaky, squelchy, harmonic feature to our filter, which I really like. I think for such simple components and such bare bones components and so few components, this thing really has like a really cool personality. So next, I'm going to put in the IC socket, If you have the option when building circuits, I highly recommend IC sockets. They've saved me a ton of time because it's very easy to burn out an IC, which an IC stands for integrated circuit. So IC sockets are really great because they're like ICs are very easy to burn out. You know, you can connect one wrong leg, you put it in backwards, anything of the sort, and they have a lot of legs. So if you burn it out and you destroy the component, you've got to desolder it all. You got to get everything out of there, and you got to resolder it. But if you have an IC socket, you just pop it in, pop it out, no problem, no questions asked. Very, very easy. I was just talking to a guy driving a truck. Whoa. So DP Dishy on Twitch has been updating me on some of the things that they've been seeing on Twitch. They're just sort of floating around. I was talking to a guy driving a truck. He was nice. That's cool. I did not know there was truck drivers on Twitch. And a guy sitting in the dark, being angry at the world. I even once came across a guy who enjoyed himself way too much on air. Very interesting. I love floating around. Yeah, that's so interesting. That's so cool. I love that idea of just sort of floating around the what's the word? The sort of like drones of Twitch. If you answer here, oh, okay. So the circuit board, I have all my cameras sort of like locked down, but I don't know if you can see. Oh, you can't really see it. So I sort of have been building these things where I build out these circuit boards, right? I make these like custom boards that have, you know, pretty wacky shapes. And so this is a filter, and this is, I did another stream where I built an oscillator, and this is the oscillator. And they basically get sort of collaged together and put on, right now I put them on wooden panels, but I'm hoping to move away from wooden panels and maybe do some like metal panels or aluminum or something. And I sort of collage them all together, and then they all have audio jacks on them, which can be used very similar to like, you know, a modular synthesizer. And then they all get jacked together with audio cables. So let me do this. Actually, I can throw a photo of a recent one that I did. So if you're on Instagram Live, if you were in the Twitch stream, you would see me pulling up a photo of one of my recent sculptures. Yeah, so this is one of them. I don't know. Let's see. Yeah, so they sort of like all get strung together with these cables. And then they have like a sound output. So this middle blue one is like a mixer, and so they all get sort of fed in there, and they all have different functions. This one has some VCOs, some filters, some clock dividers, which sort of automate everything, some VCAs, which are voltage controlled amplifiers, which open and close sort of the gate of them. So, you know, if the amplifier is totally shut off, you don't hear the sound from it. But if it's open, then you can hear it coming through. So the combination of the amplifier and or the VCA, the voltage controlled amplifier, and the clock divider gives a very like, you know, modulated, automated sort of like long-term rhythmic complexity, which I really like. But I am going to close this, and I'm going to open up. There we go. Back to the circuit. Oh, thank you. I appreciate it. Yeah, this is. I agree. It is very fascinating, and it's the nitty gritty of it is very confusing, and it's something that I still don't have like a full grasp on. And I've like sort of been doing this for a couple years now. I just sort of like, the software is really dense, and I sort of slowly picked it up. Like up until a couple months ago, all of my boards were just rectangles and very basic. As I sort of was like learning everything. But we're very close to being done with this because it has so few components. So I'm going to sort of just like power to the end of this, I think. So here's, the last thing we're going to do is put on the audio jacks. So we have the control voltage jack, the output jack, and the input jack. Cool. Now I'm gonna solder everything up. I will say though, when it comes to learning about this stuff, that one of my favorite parts about getting into this sort of stuff was finding like how massive the online community is, and how there's just so much free information available. Like I didn't study any of this sort of stuff when I was in school, and now it's sort of like what I do all the time, and it's just because like the resources online are just so powerful, and they're all free, which is insane. So now I'm gonna use some scraps from earlier. So now that that's all soldered, I'm gonna connect power, and we can plug this in. Actually, last thing we need to do is put the IC in. Cool. So I also, these circuits run on, because they have a high amplification that they need, because we're working with like, very low level things. They run on, your normal circuit will run on like your phone charger. You plug it into the wall, which is like AC voltage. It turns it into probably like 5 volts DC, which means that at the 2 poles that you have, there's 2 wires, right? Positive, negative. The difference there is 5 volts. In this case, these circuits actually have 3 poles, plus, minus, and ground. Ground being a sort of midpoint. And these run on what's called plus minus 12 volts, which is sort of, you have 12 volts above ground and 12 volts below ground, and between your 2 above and below, you have 24 volts difference in voltage. And that just gives you like a better range of power options and amplifications. But it means you have to have a special power supply, which I have, but that's why there's 3 wires that have to get connected for power. So one thing that I didn't do on this board that I wish that I did, that I've done on my other boards, which is really handy, is putting power indicator lights. And power indicator lights are little LEDs. I have them on this one. That don't really do anything in the circuit other than just show you that it's successfully getting power, which is really handy with debugging, because if you plug in the circuit board and the lights don't light up, that's like a red flag right off the bat. And so in this one I don't have those. I wish I did, but here we are. Here we are. So I'm going to just strip the ends of these, and now I'm going to get some power. We're going to plug this in, and hopefully it works. What time are we coming up on? Half an hour. Wow, record time. We're really flying through this one. Very, very simple circuit. Plug it in. Hopefully no smoke. Looks good. It's not heating up. One thing that is a very clear sign that you've done something wrong with your circuit is if the IC gets really, really hot really fast. So I always check to make sure. But now what we're going to do is plug in some audio. I'm trying up a new audio setup this time. I have a very tiny little mixer plugged in with everything. So I'm going to go output up here. Input up here. Cool. Got a audio cable. Plug this guy. I'm gonna plug this in. So this guy this is one of my modular units. It's a series of modular synthesizer style, instruments and utilities. So we've got a oscillator with triangle, square, and sine wave, which is basically the same thing that I built last time. I've got 2 copies of an oscillator that only has square and triangle, which was the first one I built. I've got 2 filters. These filters are the same. It's the same circuit. Dual envelope, 2 sets of dual Vactrols, 2 sets of multiples, 2 samples and holds, and a noise module. Just because of utility, I just kind of needed these specific ones. So I'm going to take a triangle wave and I'm going to plug that in. And let's see. Let's see if we can get some sound. So we can already hear something coming through, which is really good. So I'm going to adjust the frequency now. So you can hear as I turn the frequency knob, it opens up a lot, and there's a lot of sort of like resonance coming out with it. And now I'm going to do the same thing, and I'm going to add the resonance knob. Yeah, so it's got a really nice, like, harmonic spectrum to it. And for reference, the actual sound that that's filtering is just a triangle wave, which sounds like this. You know, so to go from that very basic triangle wave, very basic sound wave, and jump to what we heard just like right before this with the frequencies and the resonance, that sort of like crazy harmonic soundscape is just like such a powerful utility. Now, for everybody on Instagram Live, I'm going to just basically just swap over to my amp. It's not going to sound as good, but I don't want to give you nothing. So that sound is just the bare, unfiltered triangle wave. So, sounds like. Yeah, so I can adjust pitch, very basic. So now I'm going to feed it through the filter. And everything's turned down, the resonance turned down, the frequency is closed all the way. Or I'll open it all the way to start. So it sounds very similar. Sounds very similar. And because it's turned up all the way, we get a little bit even more out of the high-end spectrum. But now the exciting part is when you start adjusting the frequency and the resonance on here. So I'm just going to sweep the frequency. Yeah, and so you get a whole range of different sounds as you just sort of like, you know, close the frequency down and sort of pull out a lot of the upper frequencies. And now if you combine that with the resonance, you get even more feedback and you get a lot more of like a punchy, really like gritty sound. Yeah, and so then that's sort of it, you know, being swept through manually. But the cool thing about, you know, modular systems and sort of using control voltage as a way to adjust the circuit is that now I can plug a signal into the control voltage and let the circuits all automate themselves. So let me find another let me find another cable. Here we go. So now I'm going to take this sample and hold module, which sort of randomly will grab a signal as it just sort of like, you know, every time it's triggered, and it's triggering on the internal clock, so I can slow it down a bunch, or I can have an external one. And so I guess this is gonna take a second, but maybe I can plug. That's kind of far. I'm gonna plug something into that. I'm gonna get a really long cable. Because I'm realizing that this sculpture back here has a clock divider in it, and I can use that instead, and that'll be simpler. But I need a really long cable to get to it, so let's see how this works. I've got a very long cable. This. So the downside is that this is going to just sound like open or close. It's not going to have, like a range if I was giving it through like a sequencer or something, and I had a knob that I could adjust. Sample and hold, if I'm putting in like a range of frequencies, it can give me any frequency. So it can give me like a very low one, a middle-sized one, or a very loud one. This one's just going to give us on and off, which will still have a sound like an audio effect, but won't be as exciting. So the sound without it, right? So this is, I'm going to turn it up, and this is what it sounds without the automation. And then with the automation. There you go. So there's a filter. Yeah, I love this thing. It's got so much like, as far as like expressiveness goes, I feel like this thing is just like, it just screams. Like you can make it really, crow, or you can make it like a deep house bass or something, or it sounds like somebody talking in the room next to you through a wall. Yeah, and it's so few components. I can't speak highly enough about this circuit. It's sort of a circuit that I found online. It's based off of like a low-pass filter-esque, circuit that's used for like guitar amps, and it was designed to be a foot pedal to turn your guitar into like more of like a synthesizer or something. And so I sort of, jumped off of that circuit and added, a CV input, changed some stuff around, added a resonance, and piggybacked also on some other designs that I found online. But yeah, that's sort of the whole thing. It works right out of the box, which is really nice. We haven't had any smoke or issues in these builds, which has been really nice, knock on wood. And yeah, we're at the 49-minute mark, which is kind of nuts how fast this one is. But yeah, thanks for tuning in. I think that's all from here. Enjoy your weekend, everybody. Stay safe. Don't catch corona.